Okay, welcome to 6.6. We are introduction to rationals. So what exactly is a rational function? And what a rational function is that it's a function where we have p of x and then we have q of x, where both of these are different polynomials. Okay, so a fancy way of saying a rational function, it's a function that is in a fractional format, right? There's a function in a fractional format. So you can see right here, that example, these are all fractions, right? We've got polynomials, different type of polynomials. Okay, all right, so let's go and take a look at something that we've talked about a lot, which is undefined, all right? And where a function is undefined is where the denominator is equal to 0, right? The denominator is equal to 0. For example, you can't have 3 slices of pizza, right, if you don't have a pizza, right? That doesn't really make sense, okay? So undefined is an important kind of concept. And another concept here is rational functions have asymptotes. Okay, this word right here, asymptote. They can either be horizontal or vertical, right? So they can be horizontal in this direction, okay? So for the horizontal asymptotes, the things that we need to look at is the following information, right? We need to look at how the powers of the function. So we can see this polynomial on the top is a degree 1, or a linear polynomial, and you can see this is degree 2. All right, so what we call that is bottom heavy, right? The powers are larger on the bottom. So as you substitute in larger numbers, really what happens is it approaches y equals 0. As we approach infinity, it's going to approach y equals 0. So there's a horizontal asymptote at y equals 0, okay? And the next function is what happens if we have an equal power. We've got equal powers right here. Got a degree 2 on the numerator, a degree 2 on the denominator. So what happens here is you're only going to look at the coefficients of those highest powers, and you're going to get a horizontal asymptote at the line y equals 2/3. And then the third version of these horizontal asymptotes is what happens if the numerator is larger than the denominator. And what I mean by larger is there's a larger degree on the top. So you can see I got a 3rd degree right there, and then I've got a 2nd degree right there. So this is a top-heavy function. Okay, and what that means is that there's no horizontal asymptotes, right? So what that means is as these numbers get infinitely large, there will be no place that approaches a specific point, okay? Right? That may be a lot to handle, so let's kind of take a look at how this kind of works out. All right, so first of all, if I want to look at the horizontal asymptotes here, okay, I can technically think about this like this: x to the 0 and then x to the 1st power. Right? I can technically think about this is x to the 0 and this is x to the 1st. So this is a bottom heavy function, right? It is bottom heavy. Okay. And now what that means is that y equals 0 will be our horizontal asymptote. Okay. That is the horizontal. Okay. Asymptote. And for the vertical asymptote, now that is where we are looking where the function is undefined, okay? So cross this off right here. Somebody made a mistake. I don't know who it was. But this is a vertical asymptote, okay? And what that is, you've done this already. It is where is the denominator equal to 0. So if I add 7 and add 7 to both sides, x equals 7. Here is our vertical asymptote. Okay. All right, so now we got a horizontal asymptote and then one vertical asymptote. Okay. Now let's look over at this next example right over here. Again, we have x to the first power, x to the second power, okay? So this is bottom heavy, okay, which means that y equals 0 is our horizontal asymptote. And now in the denominator, we want to know, okay, where is this equal to 0? So this is where you're going to have to factor, all right? And we notice that this is a difference of two squares. So this would be x plus 8, x minus 8 equals 0. So now there are two vertical asymptotes. One at x equals negative 8 is 1. And then there's another one at x equals positive 8. Okay, so these are where the function is undefined, and this is called a vertical asymptote. Okay, moving on to this third example right here, you can see that both of these are linear and linear. So if they are the same power, if the degree of the numerator is equal to the degree of the denominator, you're going to get an asymptote at the coefficients of the leading terms. That's where it's important that we learn the leading terms, right? So here we are going to get an asymptote, a horizontal asymptote at the line y equals 1, 6, all right? Horizontal asymptote. And then for the vertical asymptote, again, where is the denominator equal to 0? Where is this undefined? So if I solve for x here, I'm going to get at x equals 6, there is going to be a vertical asymptote. Okay? All right, last example coming at you right here. Okay, I'm going to take a look at this. Whenever I have a polynomial in the denominator, what I'd really like to do is, what does this simplify to, or can this factor in it? All right, so are there any factor pairs of 42? And then I can really simplify this. I can break this down into x plus 6. And then x plus 7, because 6 times 7 is 42, and 6 plus 7 is 13, all right? So I always like to think about these and then transfer that. Okay, but now you got to realize that I have a second power here and a first power here, so this is also bottom heavy, which means that there is a horizontal asymptote at the line y equals 0, okay? The line y equals 0 is our horizontal asymptote. And now, to determine our vertical asymptote, where is this equal to 0? So I know if I substitute in negative 6, our function will be undefined. And then I know if I substitute in negative 7, our function will be undefined. So there are two vertical asymptotes. Right there, okay? So real quick, what does that look like on a graph? So we're just going to take a look at this one right here and take a look at it on a graph, okay? So if I go ahead and take a look at the graph of this function, right, I've got alpha y equals, let me throw it into a fraction, okay? On the top, what was on the top? We've got x minus 9, and on the bottom, we got x plus 6, and then x plus 7. So if I'm going to substitute in x minus 9, and then I've got x plus 6, and then x plus 7. All right, now if I take a look at the graph of this function, you can see here is these two dashed lines, right? Right at x equals negative 6 and right at x equals negative 7, right? The graph will never touch it. It'll get closer and closer and closer and closer and closer, but it will never touch it, okay? No matter how close, how far down we go, it'll never touch that line. And the same thing is true. And so let's get back up to 0 here. And the same thing is true for 0, right? It looks like it might touch 0, but as we zoom in here it's just going to get closer and closer and closer and closer, but never actually touch zero. So that's what we mean by an asymptote. Okay? All right, y'all, good luck.